So I'm going to talk about consciousness. I'll talk a little bit, but not too much about the brain, because this is not a neuroscience audience. And then I'll directly speak to the point of consciousness and reality. This is an experience. This is the conscious experience I had at the so-called near-death experience early on during the pandemic. It's an example of a conscious experience, a blazing point of pure white light of unbearable intensity without the conceivability of looking away. There's no way from. There's no space. Everything is contained in a point of pure energy. There are no other visuals, no color, no motion, no texture, no depth, neither sound nor silence, neither pain nor pleasure, no feeling of a body, no self, no ego, no memories, no desire, neither hope nor fear. No sensation of the experience being too brief or too long or wanting it to end. There's no time. There's only terror and ecstasy, that and the icy bright light. So it's a singular conscious experience, and which has little content. There's only this feeling of terror, ecstasy, and then this bright light. This is another conscious experience. This is sort of more of an everyday experience, you know, running here through the temperate rainforest. Though my calf muscles burn with fatigue, I will my body to continue to run along the forest trail. Looking ahead to avoid roots and rocks, I hear the caw-caw screech of crows in the canopy while thinking about a work-related dispute, but come to an abrupt stop to admire the breathtaking beauty of a beam of the rising sun slipping through the dark forest and striking a moss-covered tree, reminding me of a famous poem. So this is sort of what William James calls the stream of consciousness. It's filled with, you know, percepts. It's filled with, you can feel your body. You have this the feeling of wanting or pushing yourself. You have memories, from the past, and you project yourself into the future. In this case, about a work-related dispute. Both are conscious experience. Both are ineffable, and both at this point don't really fit within the standard scientific framework of physics, chemistry, biology that has been so successful at explaining everything around us. But not this central fact of our life, the fact that we do have feelings. We do have experiences. We call them subjective, call them qualia. There are all sorts of different names: awareness, consciousness, experience, subjectivity. They're all different names, but they all refer to the same ineffable thing that we all have. When we don't have it, we're either in deep sleep, or we are anesthetized, or we are in coma, or we are dead. And then we are no one to ourselves. All right. So you'll hear from a diversity of speakers that speak to consciousness. Many of them are influenced by a particular tradition in Anglo-Saxon analytical philosophy, where there's sort of this widespread sleight of hand where consciousness is sort of replaced by what consciousness does. So rather than speaking to phenomenology, which is the central fact that has to be explained, people try to explain the function of consciousness, which is a perfectly legitimate question, but the function of consciousness does not address how the phenomenology comes about. Consciousness can be dissociated from computation, behavior, intelligence, planning, reasoning, social cognition, top-down attention, and working memory. It relates, of course, very often to those, but it can also be dissociated. In fact, you can get two ways dissociation, where you can get reasoning without consciousness. You can get social cognition without consciousness, and you can get consciousness without reasoning or social cognition. So it's really important to keep that in mind. The central problem is phenomenology. And as Erwin Schrödinger has remarked, phenomenology comes prior to physics. So before, even to talk about particles and accelerators and telescopes and measurement devices, well, I need to look at them, right? I need to interact with these devices. So it presupposes a conscious observer. All right, and then just a fun reminder here, every perception. So when we talk about perception, which is where most of the scientific experimentation has happened, whether that's a visual perception, auditory, tactile perception, etc., it is always a construction. In David Marr's word, every perception is a construction of a description. Right, so this argues against this sort of naive realist view. We see this here. right? This is the so-called dress, right? Came out, went viral in 2015. About half of people will see this as black and blue. And the other half of people will see it as white and gold. Like for me, it's white and gold. There's just no dispute. It's not ambiguous. It's not like one of these percepts where you can flip from one to the other. A small set of people say they can flip from the white gold to the blue black interpretation, but most people see it either one or the other. And you can't say one is more right than the other. What it shows that that conscious perception is a construction, and it depends on all sorts of assumptions. In this case, we know it depends on assumption your brain is making about the general lightness, the overall brightness in the image. Anyhow, this is important to remind us. What we perceive, isn't sort of some Ding an sich, isn't a reflection of a Ding an sich, but it's a construction of our brain shaped by the forces of evolution. Right, so so typically when I talk about consciousness, I speak about four aspects, because they have really have undergone tremendous change and progress over the last sort of 30 years. Pietro mentioned I first started to engage in this when I was at Caltech back in 1990s. Was my first paper 32 years ago on consciousness. So I'll talk a little bit about isolating the neural correlates of consciousness in the brain, tracking them. That's been the most progress. I won't talk about psychedelics. They are a fantastic tool to manipulate consciousness, of course. Then I'll talk about integrated theory of information, and I'll talk about biomarkers for consciousness. All right, so as I mentioned, I started this a long time ago with Francis Crick. Was commuting down from Caltech every month down to the Salk Institute, where Francis Crick at the time was working. And the idea is, independent of what philosophical attitude, no matter what ism, materialism, physicalism, dualism, or any of the shades of isms in between, we can all agree the brain is the organ of consciousness, not the heart, like most people in most cultures thought. It's the brain. And so we can look for the footprints of consciousness in the brain. So they're called the NCC, the neuronal correlates of consciousness, the minimal neuronal mechanisms that are jointly sufficient for any one conscious experience. So you can ask, when you see a German Shepherd, what mechanisms, let's say, what neurons? One interpretation says, well, it's all neurons that fire. Well, what is it about those neurons that fired in response to the German Shepherd that give rise to the conscious experience of a shepherd, while other neurons that are nearby that are also firing don't seem to be involved in the conscious experience? Where's the difference in NCC between seeing a dog or a cat, seeing it in color or without color, in stereo, hearing about a dog, dreaming about a dog, recalling in my dog, with the difference between, vision and audition, having strong positive feelings for a dog, all those different aspects. You can, furthermore, it's a causal. It needs to really go deep. It needs to move away from mere correlation to causation. So the idea is that if you induce the NCC by a TMS device, or by a neurosurgeon's electrode, or by optogenetics, or whatever other fancy futuristic technology, you'll induce the experience. Conversely, if you inactivate the NCC, again, using various tools in people or in animals, you should eliminate the experience. And so this has been sort of the research program over the last 30 years of the field. It's very important. You need to distinguish the direct physical substrate of any one conscious experience from the background conditions. So these are the conditions that are necessary but not sufficient. So we know, for instance, your heart has to beat. Furthermore, your blood has to supply the oxygen to your brain through the arteries, the carotids and the other arteries. We know experimentally, and we know this from life, if you prevent oxygen from reaching the brain, you lose, quote, consciousness within 7 to 8 seconds. There's no power batteries, there's no backup in the brain, you lose consciousness. And so that's necessary, but it doesn't provide any specific content. We know this because there are people whose heart beats and whose brain is suffused with oxygen, but they're unconscious. Likewise, there are sort of background condition in the pons, in this structure called the midbrain reticular formation, it's a tube that extends, 2.5 inch here, and there are all sorts of nuclei there. They need to be intact. Typically, even small damage among these in the brainstem, in particular if it's bilateral, will typically lead to bad outcomes, including coma and death. So we know that these structures here are absolutely essential. They're necessary for consciousness, but they don't mediate any one specific content. Just like my laptop wouldn't work without having a power adapter there, right? But the power adapter, of course, doesn't compute, doesn't stream, doesn't play video, doesn't enable me to doesn't play video games. It's necessary for me to do all of those, but it's not specific. Same thing here with these enabling or background conditions. All right, so the evidence that I'm not going to discuss, I'm just going to discuss the type of evidence that you need to track the footprints of consciousness is primarily causal. I mean, the most important from an evidentiary point of view is causal evidence, where you manipulate things. So lesion studies, this is a natural occurring lesions. Typically, people suffer from a stroke, from ischemia, from traumatic brain injury, from bullets, from viruses, and all of that from the deficit that's left behind by these various calamities. Clinicians and scientists can infer which structures are necessary. So, for example, we know if you lose part of your brain, in your visual cortex, you can, for example, become face blind, or you can unable to see color, or unable to see motion, although there's nothing wrong with your eyes per se. So that's been historically the most important source of evidence about which structures, particularly in cortex, are essential for particular classes of conscious experiences. Another type of causal manipulations are stimulation studies. So particularly in the context of neurosurgery, even today, as part of a normal clinical workup, a neurologist or epileptologist, before, let's say, they take out a part of the brain because it has tumor or it gives rise to epileptic seizure, they will go in with an electrode and stimulate various parts of cortex. And so from those experiments, we know that some areas, particularly in the front, are largely silent. In other words, if you stimulate them electrically, the patient doesn't report anything by and large. If you stimulate motor cortex, the patient will twitch. If you stimulate auditory cortex, they might hear sounds. If you stimulate visual cortex, the patient will see visual percepts, so-called phosphenes. So this allows you sort of to directly intervene in the causal in the networks of the brain to see which ones have a direct relationship to some conscious experience. And people are doing this, have done this, and doing this systematically. Lastly, there's recording and neuroimaging studies that are very popular because they're relatively easy to do. You can put an electrode in a brain of an animal, you could do it in patients, or you can put people in magnetic scanner. So there's a lot of activity there. It's weaker in general because it's of course only correlation. And we've learned over the last 10 years, particularly from single cell experiments, that many states for instance, motivational states, hunger or learning or arousal, are represented in very large fraction of the brain. And so it's just not true, like we thought early on, that vision is just isolated to one part of the brain, and being highly or less highly motivated involves another part of the brain. All those signals can be picked up throughout the brain, and so that's a big confounder.